Okay, so last week saya ada minta tengok video kan. Actually video tu untuk ganti kelas esok sebab last week saya dah inform saya tak ada esok sebab saya ada kursus. Uh, so video yang saya bagi ataupun saya ask you to watch last weekend is for tomorrow class. Okay, so for today I will start the topic after the bisections okay. But before that, okay, I just want to revise again. So we have started on second chapter last week. Okay, so the method that we have started is the graphical. Okay, so what is the topics for the video? Anyone can respond? What's the topic?
Bisection, if I'm not mistaken.
Yeah, okay, bisections. Okay, good. Okay, so this is the topics basically, the things. But the example in that video using these kinds of functions, not the same function that we have in the graphical method last week. So these functions okay, FC is equal to 667.38 over C, everything here minus 40. This is an example from ebook 1. So you may refer from ebook 1. This is non-linear function, okay? So there are two expressions basically. So from the ebook we take the simplest one. This is the simplest function. The first one given is not the simplest because there are some part that you can simplify. So for the calculation we just take it the function contain the simplest one. So FC here in this example we want to solve it using graphical and then we want to solve it using bisections. Okay, so in that video, the video has explains how to start with. Okay, so the graphical methods similar to the one that I explained last week. We develop the table. So choose suitable value for your input and then you have to compute your outputs and then you must plot 10 points on your graph. Okay, and then check where is the intersections at your inputs. Then that is one of the solution. So in this FC function also, the true value is given. True value is 14.780 something. But sorry, I don't remember how many digits. But the true value is very long one. So you are supposed to write down all digits for the true value. Okay, and then let me show the ebook one first. Okay, so the example is here, example 5.1 regarding the FC. So the function that I asked you to use is here, the one that I highlighted. So in ebook it's stated in page 120. Okay, now for the bisections, this is something given in the questions. So can you see? Is it too small? Can you see the table here? The table containing C and FC value.
Can, madam.
Can Okay, so how to calculate FC? You can just substitute 4. C is 4. Okay, put it into this function. So that means 667.38 divided by 4 and then you times with the one in the brackets and then minus 40. Okay, so the simplest number is correct to three decimal places is 34.115. Okay, so you can do for other remaining values for C until 20. Okay, now for any nonlinear functions, fc equal to 0 means your root. Okay, your root means when fc is equal to 0, so c will map into a value. So that value is called as a root. Okay, now fc equal to 0 lies in this interval. You see, between 6.067 to negative 2.269. Right? 0 lies between this 6 to negative 2. Am I right? Maksudnya FC equal to 0 ada dalam interval dari negative 2.269 sehingga 6.067. Correct? That's 0.
Madam apa?
Yes, madam.
0 ada di antara negative 2.269 until 6.067.
True, madam. True.
Understand? Understand? Do you get that?
Yes.
Okay. So since 0 lies between this interval, that means your root is between this interval lah. Your root of C. Okay? Your root is your C roots lah. So the root lies between 12 to 16. Okay? 12 to 16. So for other method except graphical we didn't need to find out lah what is the interval containing the roots. Okay, we just need to refer to your graph. But for bisection, you need to choose the interval to start in your table that contains the root. Okay, so that once I have explained in the video. So you cannot choose 8 and 12. Okay, the interval you cannot choose 8, 12 in your computation because 0 is not lies between 6 to 17 lah. Okay, so you must choose interval yang ada roots. Okay, so in the bisections we choose that kinds of conditions. Okay, so that's why in the bisection, see, I mark here choose interval containing the roots A, B. Okay, so we choose 12 to 16 because this root between this interval contain the roots. Okay, we didn't know which one is the root, that's why you have to find out. But if you choose interval that did not contain the root, that means later on you have diverging. Okay, you will not be getting the roots. Okay, so that's why it's very important to choose the correct interval to start your computation in the bisection method. Okay, so in the bisections, the concept is we compute the midpoints. Okay, so C is your A plus B divided by 2, and then you need to determine the product for the value. Okay, there is a condition here lah later on, this number 3. This bisection, the tips whether to check whether the product is positive or negative is not given during any of your assessment. Okay, so you have to understand. If the product of FA times FC is negative, okay, so next step you have to follow these kinds of interval lah. If not, if it's positive, then the interval will be a different one. Okay, in this bisection, we have stopping criteria. Okay, stopping criteria using bisection, we stop whenever your absolute error is less than estimated error. Okay, if still bigger than, you need to continue the computations. But when it is less than, then you have to stop. In this example of FC, the estimated error is given as 0.5%. Okay. Okay, so this is starting. We start with the 12, 16 and then compute the C and then find out what the product. In the first row here, the product is positive. See, you can see my cursor, right? The product is positive, so if it's positive, so next interval will be C, B. You can see, your B is the same with previous B, but your C will be your A. See, yeah? Your C just now in the first row will be your A in the second row. Okay? And then for the starting iteration, the absolute error always empty. Usually will start at the second row here. Okay, so the estimated error and the relative error will be based on the basic formula that I have introduced to you during last week class. Okay, next for the second row, same thing. We calculate what is the midpoint C and then check what is the product. Okay, how do we get F14 and F15? We just wanted to know the value. Is it has sign positive number or it is a negative number? Okay, F14 and F15. How we are going to compute? F14 means that here your C is 14. So you just compute 667.38 divided by 14 and times with the one brackets minus 40, and then you will get a positive number. Okay, we just wanted to know the signs and no need to get the exact value, what is the number. And then if you change your C to 15, okay, 15. So here we have 67.38 divided by 15. And you'll get a negative number. So positive number times with negative number, you have a negative number. So if here, this is negative number, so next iteration, your interval will be here, based these kinds of conditions. Your previous A will be your A, current A. Your previous B will be your C. Okay, you can see there is a changes in the interval. Okay, so A, previous one is remains. The C, previous one will be your B. Okay, so have to repeat the step. The stopping criteria will be based on your absolute error. Okay, basically in this example, no need to compute the relative error. Here we just want to show how to apply the basic formula of relative error to see. Later on, you can compare between the methods, which method will give more accuracy. Okay, for this absolute error, the general formula is given here. Current approximation value minus previous approximation divided by current approximations. Consider everything in modulus. That means a positive value times 100%. Okay, so let's see here. Absolute error will be based on your column C. So this is 15 minus 14 because this is at this second row, current one is 15 minus previous one is 14 divided by current one. Okay, then take everything in positive, then times 100%. Then you see here, the first computed absolute error is 6.7%. Okay, so 6.7%, is it more than or less than 0.5 here? Anyone can answer my question?
More than.
Sorry, I cannot hear. Tak ada orang ke?
Lebih madam, lebih.
Okay, bigger than lah. So bigger than, still you still need to proceed the computations lah. Okay, so you have to repeat the computations and then check. Next one, you have 3.4%, 1.7, 1.7%, 0.8. Okay, and then at the last row here, see, we still need to compute your interval C. Okay, at the last row, we have A 14.75, B is 14.875, so C will be the average for your AB. And then we check the sign, positive or negative. Okay, for the absolute error, this is the computed as this value, the one that in the red circle minus previous one divided by the one in the red circle times 100%, then you get 0.4. So we can see this is the first time that the absolute error is less than your estimated error. Okay, so we stop because it's already less than the estimated error. Okay, so this is the stopping criteria for this method. For different method, there is a different condition. That means the stopping criteria will be a different one, not really based on less than. Okay, so since we find out that the absolute error is less than the estimated error, so we stop the computation. Okay, so the bisection methods using numerical one, our computed value, AV refer to approximation value. So we have as 14.8125. Okay, so the exact value is 14.7802. Let me see the numbers. Yeah, the numbers. See, I'm looking for the true value. Where's the informations? Later on you can refer back. So let's check the final value for the true value. 14.7802. Okay, so let's see. This last column for the relative error, basically, for the problem, if we are using one method, usually we didn't compute relative error, except that later on, if we want to compare this bisection with other methods, and then you can compute the relative error. This one, I just want to show how we compute the relative error. Okay. For the given problem, for any problem given to you, just make sure is it required to compute the absolute or the relative error. So you need to find out. Don't compute everything. Okay. So you just need to focus for the given problem solving. Yeah. Okay, so relative error, the basic formula is true value minus approximation value divided by true value, and then modulus times 100%. Okay, usually the final one that we consider for the relative error is at the approximation value here. Okay, so here 0.2. 0.2 is the final relative error that later on we will use this percentage to compare with other methods. Okay. um, Same things with the graphical. You can compute the relative error for the graphical, but for the graphical value, you cannot compute the absolute error because we just compute one time for the graphical. But in this bisection, you can see in the absolute error, you have several iterations, right? But for the relative error, we just compute the latest one based on the approximation value, which is 0.2%. Okay, so later when you have different method, then you want to compare, then you can compute the relative error. Any questions? So this is just for the bisections briefing, because actually this part I have given to you to watch the video last week. Any question before I proceed to the next method?
So far, no, madam.
No, madam.
Okay, so we proceed to this one, first positions. So after the bisection is the first positions. This is the slides. Okay, first positions, another method that we consider for the closed methods. We are going to, because this function is the same function, so we are going to take same information regarding the true value. So in this first position, this is the general formula. Okay, so this general formula is given here. C is the one that you are supposed to approximate, equal to B minus FB times A minus B divided by FA minus FB. So please take note that the one that is divided by only at this one, at this part. Okay, then recall back, because we have same informations, estimated error will be 0.5%. The stopping criteria for first position is also when the absolute error is less than estimated error. Okay, so in the first position, the condition to choose the interval, same thing with the bisection. So we choose the same interval because the roots is between 12 to 16. Okay. Okay, so we compute what is your FA, FB. Okay, what is FA, FB? That means what is your function when your input is 6.067, and then what is your input when what is your output when your input is negative 2.269. Okay, so you are supposed to substitute to the FC functions. FC function is this one. See this one, 6 point here. This function. Okay, so you just need to change your inputs. Input C here to the number that we have here. This is your input. And then you are supposed to get what is the value. Okay, so FA will be 6.067. This is when you substitute 12 into your FC. You get 6.067. Then FB is negative 2.269 when you substitute 16. Okay, so in this case, let's consider 3 decimal places. Okay, so once you have everything here, you are supposed to compute C. New C is 14.911. Okay, 14.911. Okay, next, we have different condition compared to the bisections. Whatever you have in this first position, you sort into interval A, B. A must be smaller number. B is your larger number. Okay, now let's see. In the first row, you have 12, 16, 14.911. So, what is the interval for the next iterations? Second row. Okay, so we are going to take 12 and then 14.911. Okay, so this one, 12, 14.911. So we sort from smallest to the largest. Okay, for the second row, you still need to find out the new output value when your input is 12 and then when your input is 14.911. Okay, so input 12 you can get previous information because this is something that we have computed before. Okay, so F12 will be 6.067. F14.911, how to compute? Okay, so this 14.911, you substitute here. So that means the output will be 667.38 divided by 14.911 times the one in the bracket and then minus 40. You are supposed to get negative 0.254. Okay, so once you have everything, all the value, then you substitute into the C formula. Then you get new value of C. Okay, so this is the step, and you will be getting latest value for C as 14.794. So you see there's a different value. And at the second row, you can start compute your absolute error. So in this case, I will just put down the number because you are supposed to be familiar with the general formula for the absolute error. Okay. So how do we get 0.79%? The step is this value minus here divided by this one. Take everything as positive value and then times 100%. Okay, you must get 0.79%. Okay, so you can see here because our estimated error is 0.5. So 0.79 here still bigger than. Then you need to proceed the computations. So on the third row, we have this interval 12 to 14.794. How do we choose the interval? You just need to sort smallest to the largest. Okay. And then compute new value of C. Okay, so same formula that we refer to. Then you get 14.782. Okay, and then we find out the absolute error as 0.08. Okay, so this 0.08 is less than 0.5%. So we stop the computations in this force position method. Okay, that means using force position method, the approximation value is this one, 14.782. Okay, any question about this force position?
So far, okay, madam.
Other students?
Okay, madam.
Okay, so now let's see which methods, because we have same functions, right? But we have different methods and so on. Okay, so let's say I want to compare which method is better, which method will give us better accuracy. Okay, so to compare the accuracy, you are supposed to compute the relative error here. Okay, relative error. So on previous slides, okay, the bisections, the estimated error 0.2%. Okay, now how about these force positions? Okay, this first position, this is the example, but we are going to take at this last iterations when this C is 14.782, the relative error is 0.01%. Okay, 0.01. So how do we get 0.01%? So the step is the true value. What is the true value here? 14.7802 minus your approximation value, which is the last one, 14.782 divided by the true value and then times 100%. Take everything positive, no negative number. Okay, times 100%, then you get 0.01%. So everything in the relative error, the column here, it is in the percentage units. Now, so let's find out force position 0.01, and then in the bisection we have 0.2. Okay, so which method will give us better accuracy? The one contains smaller relative error. Okay, smaller relative error, that means the method is better because the difference between the approximation value with the true value is very small. Okay, so that means the value for 14, the value using the one we compute using first position is uh, closer to your true value compared to the bisections. Okay, do you get about this one, the relative error?
Yes, madam. Okay, madam.
Okay, so these types of error, numerical error, you need to be familiar. Maybe in the future you are going to use this error in your final year project. Okay, so make sure you use correct term. Do not just mention the percentage the error percentage is smaller, but you didn't mention whether it is absolute or relative error. You need to be more specific. What types of error that you use in your research when you want to compare which method is better. Okay, don't just mention percentage error. You need to be more detailed. Are you using absolute error or are you using relative error? Okay, so please take notes about these measurements based on types of error. Okay, so I will update the tutorial questions. I want you to. We are going to take a break and then we will make it around we will make it at 11. See, I'll give you a few questions for the tutorial. Okay, the tutorial that I want you for today, this is a question actually. This is a question for the tutorial, for all tutorial questions. But the one that I want to check is for today. I will check at 11 later on. Is this question 5.3? Okay, 5.3. The one that I highlighted in yellow color. 5.3, use that function to solve using bisection and then first position. Okay?
Okay, madam.
Okay, so make sure you complete, and if you have any questions, then you can ask. You can ask in the WhatsApp group. But I want that the solutions been ready by 11 o'clock. Okay, so we'll meet again at 11. Any questions? Any question, class?
So far no, madam.
No, madam.
Okay, before that, please mark your attendance for the first sessions. Could you please scan the QR code? Take note about the password here. This is a password, huh? Anyone's having problem to mark attendance?
No, madam.
So far no, madam. All okay, madam.
Okay. So I will meet you again at 11, yeah?
Okay, madam.
Okay.
Madam,
You.
the tutorial is 5.3
Ah,
BNC, right?
yes. 5.3. Equation sama, tapi use two methods lah.
Okay, madam.
Okay.